Introduction to Logical Functions. Here we will look at how to construct a basic if function, understanding relational operators, using SUMIF and COUNTIF functions, Boolean logic with and or functions, and using IFERROR to eliminate errors. The if function allows you to make logical comparisons between a value and what you expect. The if function is made of three parameters. The first parameter, the logical test, returns an answer of true or false. If the logical test returns true, then the second parameter, value if true, is actioned. Otherwise, it is the third parameter, value if false, which is actioned instead. To construct the logical test, it is important to understand the purpose of a relational operator. There are 6 relational operators: equal to, less than, greater than, less than or equal to, greater than or equal to, and not equal to. Here are 6 logical tests which all return an answer of true. 147 is equal to 147. 100 is less than 200. 5,000 is greater than 3,000. 30 is less than or equal to 70. 150 is greater than or equal to 150. And yes is not equal to no. A data type with only 2 possible values, true or false, is known as a Boolean, named after mathematician George Boole. In the first example, we wish to discover the hours charged at overtime rate. The standard weekly hours are 37.5. The entry here suggests that the total hours for week are 39. Let's enter a formula to calculate these overtime hours. Equals B9 minus 37.5. The overtime hours are 1.5, but what would happen if the total hours per week were under 37.5? The result is negative, but we would like it to display 0 instead of a negative value. The current formula should only be applied if the total hours for week were greater than 37.5. We'll now edit the formula to become an if function. Entering if and an open bracket after the equal symbol allows us to define the logical test, which is B9 greater than 37.5? Adding a comma, which separates the first parameter from the second, has placed the original formula in the correct location. i.e., if the logical test returns true, then perform this formula. Adding a further comma at the end and adding a 0 defines what happens if the logical test returns false. The function is completed by adding a close bracket and pressing the Enter key. The hours charged at overtime rate displays a 0 because the logical test was false. By changing the total hours for week to greater than 37.5, the logical test is now true and the difference is displayed. In the second example, if the actual expenses value is greater than the predicted expenses value, then the status should be over budget, otherwise it is OK. We'll begin constructing the if function for the first row. After entering equals if and an open bracket, the logical test is B15 greater than C15? If true, display over budget, otherwise display OK. Over budget and OK are text values and are required to be surrounded by double quotes. Complete the function by closing the brackets. We'll copy the formula down the remainder of the column by using autofill, double-clicking on the fill handle. Only one row has an actual expenses value greater than the predicted expenses value, evidenced by the display of 1 over budget. In this next example, we have a list of payments and the date when each payment is due. We're required to display overdue in the overdue column, but only if the date due has passed the current date, which at the time of recording is the 4th of May 2021. We'll begin by placing an if function in the first row. The logical test will use a function for the current date. Today, open and close bracket greater than B9, B9 being the date due for that row. If true, display overdue, otherwise display nothing, expressed by 2 consecutive double quotes. We'll complete the function and then copy it down the remainder of the column using autofill. Only those rows where the date is before my current date display the word overdue. The SUMIF function is used to sum the values in a range that meets criteria that you specify. SUMIF is made of two parameters with an optional third parameter. The first parameter, range, is the range of cells you require to be evaluated. The second parameter, criteria, is the criteria that defines which cells will be added. The third parameter, sumRange, are the actual cells to sum, but if the range and sumRange are identical, then this parameter is not required. In this example, if a property value is above the threshold value of 160,000, we require to sum the commission values for where that is true. Placing the SUMIF function in cell C17 will specify the range to be evaluated. Then the criteria of greater than 160,000, which must be in text form, hence the double quotes. Finally, we'll specify the range to sum and complete the formula. There are three properties above 160,000 with commissions totaling 63,000. Now, rather than specifying the threshold value of 160,000 within the function, we'll use the threshold value stored in cell B17 instead. We'll edit the criteria by removing the 160,000 to leave the greater than symbol between the double quotes. Then add an ampersand and select cell B17 to complete. Now let's alter the threshold value to 250,000. There are two property values above 250,000 with commissions totaling 49,000. In this next example, from the payments list, we require the total of the payment values above the threshold value of 100. Placing the SUMIF function in cell F9 will specify the range to be evaluated. Then the criteria of greater than 100, again in double quotes. The range to be summed is the same as the range to be evaluated. This means we do not need to express a third parameter. The function is completed and we see the result. We'll now use the threshold value stored in cell E9 by editing the criteria, removing the 100 to leave the greater than symbol between the double quotes, then add an ampersand and select cell E9 to complete. Altering the threshold value to 150 now gives a different result, i.e. the total of all the payments above 150. The COUNTIF function is used to count the number of values in a range that meets criteria that you specify. COUNTIF is made of two parameters. The first parameter, range, is the range of cells you require to be evaluated. The second parameter, criteria, is the criteria that defines which cells will be counted. In this first example, we require the number of occurrences of the word apples from the items in the data A list. Placing the COUNTIF function in cell D9 will specify the range to be evaluated. Then the criteria of apples in double quotes. Incidentally, the criteria could also be expressed as the equal symbol and the word apples within double quotes. The function is completed and we see the result. In the second example, we require the number of occurrences where the values in the data B list are above 55. Placing the COUNTIF function in cell D17 will specify the range to be evaluated. Then the criteria of greater than 55 in double quotes. The function is completed and we see the result. In this next example, from the payments list, we require a count of the number of payment values above the threshold value of 100. Placing the COUNTIF function in cell F9 will specify the range to be evaluated. Then the criteria of greater than 100. The function is completed. We'll now use the threshold value stored in cell E9. Altering the threshold value to 150 now tells us there are 6 payments above 150. The AND and OR functions only return the result true or false. Both functions require a series of logical conditions. When using the AND function, all conditions must be met for the function to return the result of true, otherwise false is returned. When using the OR function, only one condition must be met for the function to return the result of true, otherwise false is returned. In the first example, we wish to establish if value 1 and also value 2 are in the range of 0 to 100. Two conditions must be met to return a true result. Is the value greater than or equal to 0? And is the value less than or equal to 100? If both statements are true, then the value is between 0 and 100. This would require the AND function. We will check if value 1 is in the correct range. After entering equals and followed by an open bracket, we shall enter the first logical test. Is B9 greater than or equal to 0? Cell B9 is currently 50, so this would be true. After adding a comma, the second logical test. Is B9 less than or equal to 100? This would also be true. After completing the formula, we see that the result is true due to both logical tests being equal to true. Now we shall check value 2 by copying the formula to the right. Cell C9 is currently 104, so although it is true that it is greater than or equal to 0, it is not true that it is less than or equal to 100. One of the logical tests contained within the AND function has resulted in false. Therefore, the AND function returns the result of false. In the second example, we wish to establish if any of value A, value B, or value C are greater than 100. Three conditions should be checked. Is value A greater than 100? Or is value B greater than 100? Or is value C greater than 100? If any of these conditions are met, then true should be returned. This would require the OR function. After entering equals or followed by an open bracket, we shall enter the first logical test. Is B15 greater than 100? Cell B15 is currently 50, so this would be false. A comma, and then is C15 greater than 100? Cell C15 is currently 104, so this would be true. Another comma, and then is D15 greater than 100? Cell D15 is currently 83, so this would be false. After completing the formula, we see that the result is true due to one of the logical tests being equal to true. Next, pupils have taken two examinations, one in English and the other in mathematics. Here we will see the different results returned by using the AND function and the OR function, and also we will incorporate an IF function to return a result other than true or false. In the first example, pupils have passed the course if their marks are 40 or more in both examinations. Therefore, in the first row, we shall use the AND function to check this. After completion and copying the function down the remainder of the row, we see that two individuals are displaying false due to not scoring 40 or more in both examinations. In the second example, pupils have passed the course if either mark is 40 or more. Therefore, in the first row, we shall use an OR function to check this. After completion and copying the function down the remainder of the row, we see that all individuals are displaying true due to at least one examination having a score of 40 or more. The third example uses the same scenario as the first, except that pass should be displayed instead of true and fail instead of false. Here we shall use an IF function with the AND function being used as the logical test. After completion and copying the function down the remainder of the row, we see that two individuals are displaying fail due to not scoring 40 or more in both examinations. The fourth example uses the same scenario as the second, except that again, pass should be displayed instead of true and fail instead of false. We shall use an IF function with the OR function being used as the logical test. After completion and copying the function down the remainder of the row, we see that all individuals are displaying pass due to at least one examination having a score of 40 or more. Under certain circumstances, a formula might return an error. However, these can be checked for by using the IFERROR function, where the error could be replaced with an alternative value. The IFERROR function has two parameters. The first parameter is a value, which could be a formula or a function or a combination of the two. If the value produces an error, then the contents of the second parameter is used instead. In this final example, we have a formula where the contents of cell B9 is divided by cell C9. Currently, cell C9 has no value, and the result of the formula is displayed as a divide by zero error. We will use the IFERROR function to display the text calculation error in the event of an error being produced by the formula. After inserting IFERROR and an open bracket after the equal symbol, we see that the original formula is in place as the value we wish to check for an error. Adding a comma, we now state what should occur if there is an error by adding calculation error in double quotes. After completion, we see that calculation error is displayed as there is still no value in cell C9. Upon entering the value of 4 in cell C9, the result is now 100 divided by 4, i.e. 25. Thank you for watching.